Hello class, this is a video on solving equations with multiple algebraic fractions. This is the second video in the series. Okay, so let's get straight into it. This is very similar, but it's just a different style of question. Okay, the method is almost identical, except there's just a few extra things that we have to take into consideration here. Oops, that's supposed to be a 3, and that's equal to 1/3. Okay, so very similar to what we did with the other fractions is we want the lowest common denominator or lowest common multiple between all the numbers that we have here at the bottom. So we want the lowest common number between 3 and 5. So we'll do 3 first. We have multiples of 3, 6, 9, 12, 15, 18. And for 5, we have 5, 10, 15, 20. I can already see there's a lowest common multiple there. We have a 15 and a 15 there. So we're going to choose 15 for all of them. Okay, so for all of these, we're going to make them over 15. Over 15, this is still a plus. That is now going to be over 15. That equals is going to stay as it is, and that's going to be over 15. For 3 to become 15, we needed to multiply. For 3 to become 15, we needed to multiply by 5, because 3 times 5 is 15, so we're going to multiply the top by 5 as well. So 3 times 5 is 15, x times 5 is 5x. Very similarly, for 5 to become 15, we need to multiply by 3. I'm going to multiply this by 3 as well. So 5 times 3 is 15. 4x times 3, that's 12x. Same thing, for 3 to become 15, we needed to multiply by 5. I'm going to multiply the top by 5 as well. That's going to be 15. For 1 times 5 is 5. Oops, that should be 15. Since they all have the same denominator, if we multiply every single term by 15, they will all cancel with each fraction. So these all will cancel, which will leave us just with the numerators here. Okay, so we have 5 plus 12x. We get, well, I'll just write it that. We have 5x plus 12x equals 5. These are like terms, we can add them. 5x plus 12x, that is 17x, is equal to 5. Dividing by 17 on both sides gives us x is equal to 5 over 17. Okay, and if we were to check that as a decimal value, we'll do 5 over 17. Change as decimal, we get 2 point. Actually, I don't like that. I'd rather just keep it as a fraction. Actually, the reason why I demonstrated to you that is it's preferable that we leave it as a fraction, even if it's improper. Let's move on to the next question that we have. We have here question B. Question B is negative 3x over 5 plus 1, oops, that's x, sorry, plus x over 8 equals 1/4, 1 over 4. Now this is where it gets a little tricky, because we have 3 different numbers here, Okay, so what I actually tend to do is just look for little tricks here, because I know 8 and 4 are already very close to one another. So I'm going to make this one here, right, change to the same denominator of 8 first. So the lowest common multiple between 4 and 8 is, it's 4, 8, and I know 8 is going to be 8, so there's a lowest common multiple there already. So this is going to stay the same. This one's going to stay the same. Whereas this, I'm going to make this, so we wanted now this to become 8. So I want that 4 to become 8. Since it's 4 times 2 to become 8, that's times by 2. We have to times that by 2 as well, which gives us 2 over 8. And now at this point, I just need to focus on 5 and 8 as my same denominator or multiple. So I'll list them out here. We get 8, 16, 24, 32, 40, 48. I think that's about enough. I reckon it's going to be 40 because it ends in 0. 5, 10, 15, 20, 25, 30, 35, and 40. Excellent. So we're going to make actually all of these over 40. Over 40. It's a plus sign there. It's going to be over 40. Equal sign stays where it is. That's going to also be over 40. For 5 to become 40, 5 times what gets me 40? Well, that's 5 times 8. So I'm going to multiply this by 8 as well, which will give us 5 times 8 is 40. Negative 3 times 8 is going to be, well, 3 times 8 is 24x. That's a negative times a positive, so it's going to be a negative 24x. For 8, for both of these 8s to become 40, we need to multiply by 5. It's going to multiply the numerators by 5 as well. This will give us x times 5, well, that's 5x. 2 times 5, well, that's just 10. They all have the same denominator, so I'm going to multiply everything here just by 40. Times it by 40, which will cancel everything there, which will leave us with the same numerator that we had. So negative 24x plus 5x equals 10. Negative 24 plus 5, that's going to be negative 19x is equal to 10, which gives us x is equaling to 10 over 19. Negative 19, because I'm dividing by a negative 19 here. Divide by negative 19, divide by negative 19. Do one more example here. We'll go with this one here, question C. Question C is x over 4 minus 4x over 7 equals 2. And now it may not seem it, but this number here, this whole number of 2, is actually a fraction. It is actually over 1. That's simple because whatever these are, we can just multiply the 1 by whatever it is. So we want the lowest common multiple between 4 and 7. So let's list them out. 4, we have 4, 8, 12, 16, 20, 24, 28, 32. For 7, we have 7, 14, 21, 28. There it is. So this, if we did 1, it's going to be 28 as well, because we can just start listing multiples of 1. 1, 2, 3, 4, 5. We're going to get to 28 anyway. So I know it's going to be 28. So 28 is our number. Over 28 minus the minus sign there. Over 28 equals over 28. For 4 to become 28, we needed a multiple of 7, so that's times by 7 times by 7. 4 times 7 is 28. X times 7 is 7x. 7 times 8, well, sorry, 7 times something gives me 28. Well, we need a multiple of 4, so we times this by 4 as well. 4x times 4, that is going to be 16x. And finally, 1 times 28 will give me 28. So we multiply the numerator as well by 28. 2 times 28, well, 2 times 20 is 40. 2 times 8 is 16. That will give me 56. Multiplying everything by 28 times by 28 times by 28. This will cancel the denominator for each of them, which will give us 7x minus 16x is equal to 56. 7x minus 16, well, 16 minus 7 is 9. Okay, so 7 minus 16 must be negative 9x equals to 56. Dividing by negative 9x will then equal to negative 56 over 9. Okay, so let's just, what's that one? 56 over 9. Is that a proper? No, it's not. We'll just leave it as it is there. Okay, so I hope that helped you, and best of luck on your mathematics.